The MT Focus 6000 makes sure you keep full control of your assembly process. The batch sequence functionality secures the proper workflow, guiding the operator and creating error-proofing workstations that leave nothing to ask for. The controller smoothly integrates with the accessories of your choice, such as smart jigs, barcode scanners, and stack lights, to name a few. Your process will be under total control, assuring maximum quality. Controls your workflow, eliminates operation errors, and assures quality. MT Focus 6000. Smart, connected, and efficient. Sustainable productivity from Atlas Copco.
Okay, good morning, everyone. Welcome to our live webinar for Industrial Revolution of Smart Tightening in Electronics. So before I start, I would like you to have a minute of your time and answer this poll on behalf of your group or your company to let us know that where do you find this webinar information from. So please have this vote before I start my live webinar, and I will start in a minute from now. Okay, just a minute. Okay, thank you so much for the poll. Okay, these are the results that I can see. Most of you got this information and got this invitation through email. Thank you very much for spending some time today and joining us from Atlas Copco to attend this live webinar from us. So without any further delay, I shall start this presentation and we will leave the question and answer at the end of the presentation. So my name is Mindy. I am the electronics segment leader for Southeast Asia, especially targeting on electronic segment. So today I will share with you about the main goals. So I'm very sure after this session, you should be able to provide a solid understanding of basic low torque tightening techniques, and you should be able to handle your assembly challenges that you face in your manufacturing line today. So I'm very also sure that you are expected to have a very high competence level in order to make some basic conclusions in your production manufacturing line where you have assembly process. And also you would like to create solutions to your company. So today we will have these main goals lined up for you, and you can ask a lot of questions if you have in your mind. So let's move to the factors impacting your tightening process. In today's world, you have a lot of product mix. You have high mix, high volume, or probably you have low volume, but you definitely have high product mix. You also have system complexity. You have human factors impacting your production line. And at the end of the day, you would like to have a great sustainability. And today, what I want to target, the topic over here is about human factors. So in a process influenced by people, there will always be errors. So in many low torque tightening processes, these are the processes that are broken down into several small steps. We are all trying to minimize the risk of failure. But also at the same time, you have been spending so much time and resources on operator training and preparing all these detailed instructions to give to them, all trying to minimize the human impact. So for a high volume process, however, even a small number such as 0.1% of yield can actually have a very huge impact in your production rate. So at the end of the day, even a tiny improvement on the yield rate can actually have a high significant impact on the results. So the question is, why are we focusing on technology over human being? Human error is the highest risk that customers have in their production line daily. I'm very sure that you agree with me that your operators have errors like in their day-to-day job. Even with the travelers that you have with them, they are still producing errors because we are all human. So the high scrap cost might just begin from a very tiny mistake by human from the very beginning. On top of these risks, the impact if the error reaches the customers or it goes undetected in the production line, this will definitely cause even higher rework and also a lot of time spent in the meetings or creating 8D reports for quality department and to your customer. So the next thing I want to share with you is the common challenges that you have in your production line. So these are the common challenges that you see: misalignment, floating screw, strip joint, dimension issues, missing components, over tightening are all impacting your productivity. So before I move further, I would like you to have another minute to have this poll on what is the most challenging tightening screw in your assembly line. So I would appreciate if you can answer this poll before I proceed further. So can you please vote for this question on what is the most challenging tightening screw in assembly line? Okay, that's great. Thank you so much for voting. Let me just share the results that we have for this poll. So I can see that floating screw has the highest, it's the most common challenge that you face. So today we will share with you on how you can eliminate this floating screw error. Okay, thank you so much. Let me continue with my sharing. So when we talk about low torque assembly tightening, when you know that you have such common challenges, so what do you do for these challenges? And do you still rely on human being, or you tend to look for technology to overcome human errors? So let's move next slide. So in Atlas Copco, we always strive to provide our customer the best solution, the best tools. So we do know that customer complain over the forum, over the internet, we do have a lot of issues on screws have been falling off from a laptop, and then you also have like sound from the strange sound from the phone when you shake it. My screen is extremely wiggly. So these are all the customers complain that you happen to have in your electronics components. So all these issues will cause customer return to your company. So this is not a good brand impact. So next, what is really important in tightening? And what if we really tell you that we do have solutions for you? So for this short video, we will show you on how torque will rotate the screw. When you are doing tightening, the screw is actually growing tension in between. So when the screw touches the joint, it will create a clamping force. So this clamping force is what will secure and also tighten your screw together with the part. And in the long run, it will not fall off if you maintain a great clamping force. But then for clamping force, it's not feasible to be measured. You don't measure force. So we measure clamping torque. So now we see the explanation video. We know that you need a screw tension to generate the clamping force. So when the screw is being tightened, it will react like a spring. It will expand. So when the screw is expanded, it will start to contract. That is how it relates to the clamping force. You do not want your screw to have a relaxation, too high relaxation, or to contract too much. And this will cause the screw to fall off, and it will loosen over time because it expands like a spring. So this is how we will overcome your good tightening in Atlas Copco's technology. So in summary, torque is actually a great reference to get the ideal clamping force, because clamping force is what really matters in tightening. So today I will share with you on our technology on why we are focusing on clamping force. Before I move further to the clamping force, we do know that you have a different type of joints, the joints that will affect your tightening process. We have hard joint, we also have soft joint. But what is hard joint and soft joint in tightening process? Many people do not know what is how to differentiate the hard joint and soft joint. So for now, I will briefly touch on this portion in order to provide you the best solution that we have in the tightening. So if your part is hard joint, when you do tightening, the maximum degrees that you can have is only 30 degrees. These are considered as hard joint. But when you have a soft joint, that means you have a plastic material or you have a semi-soft joint. But when you mention soft joint, the maximum torque that you have, the minimum torque that you have is 720 degrees, and you will still, the screw will be continue turning until it reaches the peak torque. So this is how you differentiate the hard joint and also the soft joint. So now we talk about joint relaxation. You do not want your screw to relax too much and then at the end of the day fall off from your part. So relaxation is represented by it's like a mechanical phenomenon whereby it lose over a period of time after you have done your you have completed your tightening. So all materials do suffer from relaxation. So in some of them the relaxation is very high, but in some of them if you control it properly with the right technology that you use, you can actually overcome and adapt this relaxation over a period of time. So what do I mean by that? I will share it with you on how we can overcome this joint relaxation if we focus on the right clamping force. So for facts of relaxation, it happens at all types of joints that you can never run away from relaxation. because hard joint, especially it occurs during the first 10 to 30 milliseconds when you do tightening. And if you have like semi-soft joint or you have soft joints, it is more critical because the elasticity for material is part of the joint. So with the breaking torque analysis, we define the clamping force. While the relaxation is still a little bit more difficult to measure or quantify, the good news is that there is a way to avoid relaxation by using our multi-step strategy, where we have more than one speed, and the idea is to allow the material to relax while the assembly process is being performed. Next, I would like to talk about friction, because when you do tightening, you do know that friction happens along the way in tightening. It affects like different screw size, the roughness, the surface of the screw. It all affects the friction of your tightening. Sometimes you do have the same target torque, but your screws that you use are different. For example, you have a bigger head screw that will cause a higher friction, or you have a longer track which also cause more friction, or the rough surface on your screw that that can go undetected by your naked eye. So if you take a look at these results are from the same peak torque that is being set by the user. They are setting about 5.5 Newton meter, but then if you see the final longer track screw results, there is no sitting point at all. Although you have reached the peak torque that you want, but are you sure that this is a good tightening? This will definitely result a not okay for your products and definitely will cause error in the production line and cause a line stoppage. So at Atlas Copco, we have been transforming the industry with innovative solutions since the end year of 19th century. The automotive industry over the last 40 to 50 years, we have gone through a transformation similar to what is happening now for low torque tightening. There is a huge variety of screwdrivers available in the market. We are all aware of this, each with a different functionalities, features, and we also know that each screwdriver it comes with a different accuracy and also price range. So it is not easy for a user to understand and choose the right technology for their process. So now let's take a look of overview of these screwdrivers available for low torque. So we have clutch screwdriver. It's a mechanical function, spring tension shut off. A lot of customers are still using clutch screwdrivers. We have current control without torque control screwdrivers as well. We have current control with torque control. We also have transducerized, which is a smart controller and a transducer function. So for when we talk about smart screwdrivers or we talk about smart torque, there's this current control with torque control and transducerized. These are categorized as smart screwdrivers or smart torque. So in summary, for clutch screwdrivers, it is low cost, easy to use, there's no need of programming needed, but you can only set up to a single torque value every time manually. Zero error detection technology on overshoot, missing screws, and there is no traceability at all. It is a very manual screwdriver that you have in the market. For current control without torque control, it is joint dependent, configurable speed, and normally allows a configuration of more than just one torque. But then also a very limited error detection because it needs torque verification for each tightening that you have done. Now we talk about current control with torque control. These are 7 plus minus 7.5 torque accuracy, but we can have better technology for this current control with torque control. We can have traceability. In Atlas Copco, we do have handheld and we also have automation for this range of tools. Last but not least, we do have transducerized tools as well. Transducerized tools are the highest investment that normally a customer would make, because they can measure the real true torque at every tightening. So they can adjust at a higher speed. We can detect overshoot, multiple torques without any manual adjustment like clutch screw. We also have angle monitoring, multi-step, and a lot of other technologies that you can find to overcome your production line. So if you take a look at these tools, definitely if you are moving towards Industry 4.0, or if you are moving to automation, you would definitely need these tools to help your production line, to help your company, to move you forward into Industry 4.0. With clutch screwdriver alone, there's no way for you to move to Industry 4.0 at all. So how do you specify your tightening process? Because normally the tightening process is defined with the final torque specification, which we will look further in more details and in the following slides. So now we now talk about torque control. Torque control in most cases is what customer focus at. As long as they reach the target torque, then they assume that the tightening is okay. So torque step is common, but is it reliable? So we at Atlas Copco, we have seen the transformation in other industries, for example, for automotive industry and tier one suppliers that are increasingly leaving torque step for a more advanced tightening strategies. You cannot just rely on the torque step and a final torque that does not detect variations, such as when you have missing components, when you have misalignment or bad robot positioning. There's no way for you to control or to know that what went wrong at the first place. So let Atlas Copco help you with a very fast experience, and we also help a lot of companies overcome their production issues with only focusing when they are only focusing on torque control. So normally for low torque tightening, we at Atlas Copco, we recommend 3 different tightening steps: engagement step, the rundown step, and also the final tightening step, which we call it as a third step. In this 3 step, when you are doing the first step, which is the engagement, you want to make sure that the screw touches your product in a gentle way and also secure the alignment, but not damaging the product. When you're at the second step, it is when you are looking for a very high efficiency. You want to improve your productivity. That is when you set the highest speed for your screwdriver to run down in your product. And at the final step, this is the highest quality step that is being generated, because it is where the clamp torque is being performed. You want to have a very good clamping to make sure that the screw doesn't fall off. And you want to also have a torque that you can reach, and also you want to have a minimum friction torque. So these are the 3 common steps that I would say is the best practice to achieve the quality of the end product. So for first time right, the engagement, you want to make sure that you have started at the right position for basic tightening. So a tightening is normally defined according to these 3 steps. So in this table, let me just repeat myself. In the engagement, the focus is to secure the screw quickly, but also gently, not to damage your product. At the rundown is the productivity where being prioritized, which is done at the highest speed. And then in our final tightening step is when the quality is being generated. You would want a good clamping to when it reach the final tightening torque. So a stable torque will actually create the right clamping torque. So from a tightening qualities perspective, we also look at the final tightening step. That is what is most important. So I would like to share with you 3 different methods that are commonly used in the in Atlas Copco. And the slides after this is whereby I will be spending a little bit more time on reviewing on the details of this method. So these are the three methods that Atlas Copco have today. A naturally combine a high quality technology that is being installed in the process of each tightening. So target torque with angle monitoring, torque seating monitoring, seating control strategy. So what is torque control with angle monitoring? If a tightening is performed and also meeting the expected angle to the end of the window, if you have a window over here, which is the angle, so instead of tightening just to reach your target torque, you would want to have a good angle that you can make sure that you have a successful tightening. But if you have a screw that is tilted at the very beginning, this can help you to detect many common tightening issues such as misalignment or missing components in your process. So when it is not meeting the angle that you set, our controller will let you know that it is not okay. So the goal of a good tightening is always to ensure a good clamping force. So the good clamping force as a reference is the clamping torque. So even though angle monitoring can help you to detect some process variation, it is still not focusing on the core of the tightening. Why do I say so? Is because when you look at this torque control with angle monitoring, there's no info about clamping torque. So in this graph and is in this animation, if you look at it closely, there will be a dimension difference in the joint between two screws. So the first one will be slightly wider. It gives a successful tightening. It ensures a good and stable clamping force as indicated by your user. The second screw is also, there's a friction which is slightly higher, but when it reaches the angle that you set, it is also showing okay. But is this a real okay? It is actually having insufficient clamping, and in the long run, this screw might fall off. So if angle monitoring is not enough, how can we improve the error detection? Monitoring torque control and angle is not enough that we might have the correct clamping force. So in real manufacturing, it may cause rework or customer return. And how do we overcome this issue? So let's take a look at the next slide on how Atlas Copco's technology has helped a lot of our customers to solve and eliminate all their assembly issues. So when we talk about torque seating monitoring, what is torque seating monitoring? The previous real case example is the solution proposed to use torque seating monitoring to overcome if you are just using angle monitoring. So torque seating monitoring, it actually enables a stable final torque that you set. Probably your end customer gave you like a 2 Newton meter to have a final torque. But at the same time, we monitor the clamping torque, which is the best reference for clamping force. So let me repeat again, clamping force is complicated to be measured. So we only measure on a clamping torque, which is the best reference. With our MTF 6000 controller that we have, it is an advanced tightening strategy that is surprisingly very easy to install, easy to program, and is also very light. So some of you might already know how to use this, but we can also contact me if you would like to have a demo, product demo on how this works. But today I just share with you on how torque seating monitoring is actually helping our customer to solve their day-to-day line issues. So if you look at this screw doing tightening with a three-step, engage, seated properly, and it reached the target torque with a good clamping, these are considered a successful tightening. Okay. So if you see the second screw, it is also a three-step that you set, engage, run down, and also reach the peak torque. But without a good clamping torque, our technology, our controller, we can allow the customer or the user to know that you are actually having a bad tightening. So this is being triggered first time when you do tightening. So we want to have a first time right process to eliminate all the floating screws and also all the problems that you have. So if the clamping torque is detected to be too low when you set like maybe probably the clamping torque is about 2 Newton meter, but when the screw is not reached on the clamping torque that you set, it will show by the controller, it will show not okay. So based in this case, even the dimension issues of the screws, you can also detect this error. So there are many benefits with torque sitting monitoring as listed here. Installing torque sitting monitoring, all the benefits from the torque strategy, we can easily install. However, torque sitting monitoring only detect process variation, but it doesn't compensate. How do I explain it to you? It doesn't compensate on process variation is because if you have something like extra parts that you want to do tightening, all screwdrivers in the market, we do not have a sensor, we do not have a camera to let you know that there's a missing parts or missing items. But from torque sitting monitoring, if you control on the clamping, this in a way you can know that something is wrong with your tightening. So that is how we detect on the missing components. We detect on the floating screws or the dimensional issues. So by focusing on the clamping torque, this rework part can be avoided. And this strategy is also presented in the following slide that I will share with you. Like what I mentioned just now, we do have sitting control strategy. So sitting control strategy is another strategy that developed by Atlas Copco to define the torque based on the clamping torque. At the sitting point, if you can see over here, after engagement and after rundown, you will have a sitting point. This adds the desired amount of clamping torque. Clamping torque happens after sitting point and until it reaches the peak torque. For example, if the friction varies during tightening, so will the final torque. But with sitting control strategy, the clamping torque will be consistent because when you set in your parameter, you set the right clamping torque that you want. Why I said so is because final torque is calculated the entire time during tightening, but the clamp torque is only calculated after the sitting part over here, after engagement, after rundown, when you have the sitting point. So this is also the most advanced tightening method in the market and also the best strategy to achieve a stable and consistent tightening process. So in sitting control strategy, the final torque is not what we are targeting. We are targeting on the clamping torque. So right here, sometimes we do have customer uh, setting the speed and other settings that they want, but do not prioritize on the final torque. Then you can use this strategy to overcome all your issues in your line. So let me just share with you a short animation for sitting control strategy. So in this industry, mostly only use target torque, right? So did not consider on the clamping torque or the torque verification. So they use the final torque as a guideline, but the final torque, as I mentioned before, there's external factors that impacting. But with sitting control strategy, even you have extra component that you're doing tightening and unwanted components when you're doing tightening is being placed under the screw, with sitting control strategy, we can manage to capture and also manage to detect these error that you have in your tightening without relying on human. So it is also very easily to install. It can be detect in most of the errors, and clamping torque is always the best available reference. You only set once for your parameter settings. So in summary, we do have torque control, we have torque control with angle monitoring, we have torque sitting monitoring, We have seating control strategy. These are all a very high technology created in innovative creation by Atlas Copco. So to quickly recap, I would like you to remember these key points on what you have to learn today. Atlas Copco Tools Solution, we not only provide you tools or the products, we actually provide you a full solution that can help to solve your common challenges in your manufacturing line. It is not just promoting on the products. We would like to have a full solution that you can find it in a market as well. But in Atlas Copco, we would like you to have a full understanding, a full knowledge, and to know what you are doing in your day-to-day job in your assembly process. It's not just about using products alone, but to have a knowledge in tightening is also very important for you to understand further and also to solve your day-to-day challenges. Today, I also share with you on the knowledge of Atlas Copco Advanced Tools Technology with Tightening Strategy. That strategy like toxicity monitoring, like seating control strategy. You also know about the soft and hard joint, which is the best solution to use it. And many customers, they are not aware of these joints. So today, I hope that you have understand on what kind of joint in your production line today. So if you have any questions that you want to raise it right now, but then before I proceed to question, I would like to have a last poll, just a minute of your time to answer this poll question before we proceed with the question and answer. So can I have a minute of your time to answer this distributing poll? What is the first priority to implement in your production line? Whether to improve the quality of tightening, reduce defect traceability, or tightening automation. Let's have a minute of this poll, and then I will proceed with question and answer. Okay, thank you so much for voting. Let me just close this. So many of you would like to improve the quality of tightening. Yes, we can help you to solve and improve the quality of tightening in your manufacturing line. You would also like to have a reduced defect. Yes, and tightening automation. Yes, we do have products for tightening automation as well. Traceability. Yes, if you like to proceed with Industry 4.0, definitely traceability is one of the top factors that can move your company and yourself to Industry 4.0. So now let's move to question and answer. So if you have any questions, you can type it at the question that you can see on your right. We have a question here. How do we know the type of joint? So the question is, how do we know the type of joint that you have? If you have soft joint or hard joint, some of you might have semi-hard, semi-soft. The recommendation that I will recommend to you is always run a sample, at least 50 times of samples. You collect the data, and if your angle that you are doing is below 30 degrees, then it's always on hard joint. But even but if you are doing tightening, and when you are doing when you set up the angle, it hits above 30 or it hits above 720 degrees, that is when your product is at the soft joint product. So it is, yes, thank you, Iman. So it is always to know your angle when you're doing tightening, whether it's hard joint or it's soft joint. Sometimes you might also encounter semi-hard, semi-soft. So I would advise you to always run a sample. Run a sample, collect a data of at least 50 times tightening. Then you will eliminate the confusion between hard or soft. Thank you. I think I answered the question. So we have next question. How to ensure the quality of tightening if using screwdriver with robot? That's a very good question. So when I mentioned earlier, if you rely on human being, maybe you can still rely on human being if you are using a handheld tightening tool. You rely on them to look at the screws if it's floating or if it's not engaged properly. It's a 50-50 if you rely on human. But what about automation? When you are having automation, there's no human being involved when you pick and place the screw into your products. So with Atlas Copco's tightening strategies that you have, what we have today for you, with torque sitting monitoring or with sitting control, when we engage the screwdriver with the screw into your product, with this technology, it can capture the right clamping torque. You do not have to care about whether today or tomorrow will it be a screw falling off. In my automation line, will it be a line stoppage? Because you are only relying on technology, you do not have to care about human error at all. So the controller will automatically let you know you are having a bad tightening, or there's this rejects happening in your automation line with robot. So with our technology from Atlas Copco, we can eliminate all these tightening issues even if you are using a robotic arm. So with our technology, we can help solve your problems, your day-to-day problems, even if you're using handheld or even if you're using a robotic arms like for your automation line. Thank you. Thanks for your question. So we have next question. Okay. So if anyone would like to know more information or have more questions, please feel free to contact me. This is my email address, if you can see it from the screen. Okay, we do have more questions. So if you can see it from the screen, this is my email address and my contact number. If you have questions that you would like to ask me privately for your products, please feel free to email me at any time, and I will try my best to answer you. Okay, we have another question. I think torque control does not provide 100% of floating solutions. Can you elaborate on this? Yes, if you are only focusing on torque control, that means our customers, when they do not know about Atlas Copco technology, they always focus on torque control, which is controlling the final torque. If their end customer give them a 1 Newton meter or 5 Newton meter, as long as they are setting up their production line to meet the final torque of 1 or 5 Newton meter, they thought that they have already meeting the highest quality of the product. But actually, this is not helping them to solve their floating screw issues. Not only floating screws, you will have a lot of overshoot issues, or you have a lot of other solutions that you want to fix as well. So with Atlas Copco solution, like the technology that we have, the sitting control monitoring, when you set the clamping torque after running some samples, when you set the clamping torque, you can actually let the controller detect it, and not human being detect your errors. So these are the technology that our R&D in Atlas Copco we have run and helped a lot of our customers to solve their issues of floating screw. Okay, so I think I have already answered this question. So I hope I answer you. But if you have any further doubts, you can still email me privately. So let's move to the next question. Do we have any solutions to check residue torque for low torque tightening? So when you mention check residue torque, there's a lot, it is a very subjective question that you have. It's a good question, but it's also a very subjective question. Sometimes a lot of customers, they ask about overshoot torque or breakaway torque. So this is actually depending on your products that you have. Some customers, they do have a product that is a semi-soft joint, and they also do a lot of tightening whereby it's a tightening whereby they need to do tightening one, and then they jump to the left side or the right side tightening that we recommended them to do. So when you mention about residue torque, we will be answering you in for today, I will answer you in a subjective way, but then if you have a sample that you can send it to us, I will answer you further, because we need to run some samples. We need to study your torque, the results that you have with your products before we set the right clamping torque to overcome your issues. Okay. So please email me your product. Please email me your target torque or your readings, your just your results of your tightening that you are facing in low torque. And then I will answer you in privately in more details. Yeah, thanks for your question. So we have next question. How to ensure? I think this question is a repeated question. How to ensure the quality of tightening if using screwdriver with robot? I think it's the same question as previous. So do we have any other question? Okay, the next question. How we can calibrate a tool which mounted on a robot easily? That's a very good question. Okay, when customers, they are using handheld tools, they usually do a torque check. They do a torque check easily because it is handheld. They can move the handheld tools and do a torque check at anywhere that they want. But if your tool is mounted on a robot, how are we going to solve this issue? You do not want to remove the tool from the automation system, and then when you plug it back, you will waste a lot of time doing this integration part. So in Atlas Copco, we do have another product which is we call it QA station, which is also a torque check system, a full torque check system that you can mount into your robot, into your whole system, consists of your robotic arms into your integrated system easily. And then when you do when you do your tightening, you can always twitch and also do a torque check at the same time. So these are the new product that we have recently launched about 2 to 3 years ago, and it is very high demand as well, especially for our automation customers. They do not want to remove their tool from their automated system, and this has actually helped them to solve a lot of return of investment, help them to save a lot of time, because they can calibrate and also they can do a torque check easily. But for a tool calibration, it is actually different from a verification. So if you have a calibration information that you need to know further, I can explain it to you in a private email and in more details, because calibration, we definitely need to do calibration for all the tools in the market. There's no tools in the market that you do not need to do calibration at all. Yeah. So do you have any other question? I think, yeah. So, okay, I think I have already answered most of the questions, but if you do have questions that you're still in doubt, feel free to email me or you can contact me as well. So, yeah. So thank you very much for spending an hour of your time this morning to attend our live webinar and live sharing session. So, yeah, so let's end this and have a good day.